And finally, we move on to the last part of our discussion on vector algebra, the third type of vector multiplication, vector product, in which we multiply two vectors together and the answer is a vector quantity. The vector product is also known as the cross product. Cross, because if you look at the equation for vector product, we use a cross or X mark to denote the multiplication. So vector product, cross product, they are the same. In vector product, two vectors are multiplied together, and as mentioned, the result is a vector quantity. So you have vector C is equal to A cross B. Vector C is equal to A cross B. You have the vector product. Let vector A be this vector and vector B be this vector. Draw them such that their tails are connected together. You'll be able to see the angle between A and B, the angle difference between the orientation of A and the orientation of B. Angle theta. Now, since C is a vector quantity, it has two informations contained in it, magnitude and direction. To determine the magnitude of vector C, we just use the following equation. Magnitude C is just equal to magnitude of vector A times magnitude of vector B times sine of the angle between vector A and B. That will give you the magnitude of vector C. This equation will always give you a positive answer, as it should be, because magnitude of a vector should always be positive. Now note that in trigonometry, sine theta will also give you a negative answer, but that's only for angles greater than 180 degrees, less than 360 degrees. For the purposes of our vector multiplication, the angle theta will not exceed 180 degrees, so sine theta will always give you a positive answer. So positive, magnitude of A, magnitude of B, positive, sine theta positive, magnitude C will always be positive. Again, it should be positive because it is the magnitude of a vector of vector C of the vector product magnitude, so it should always be positive. For the direction, we use the right-hand rule. So called because you use your right hand to determine the direction of the vector. We are multiplying A and B together, vector A times vector B, A cross B. The first one in the equation is A, so we'll refer to A as the first vector, and B is second in the equation, so we'll refer to B as the second vector. So, first vector A, second vector B. if you reverse the multiplication, B cross A, B will be the first vector and A will be the second vector. So please take note of that. That will be very important in using the right-hand rule. So in this equation, A cross B, A is the first vector, B is the second vector, and C, of course, is the vector product. So to use the right-hand rule, draw the vectors, say vector A, vector B, so draw the vectors, connect them tail to tail, connect their tails together, and then place your right hand on the drawing, orienting your hand such that your thumb is pointing in the general direction of the first vector. So first vector is A, so point your thumb in the general direction of vector A, of the first vector. And then the rest of your fingers point them in the general direction of the second vector. In this case, vector B. Point your fingers in the general direction of the second vector. And wherever your palm is pointing, that is the general direction of the vector product. Of the vector product C. Bearing in mind that C must be perpendicular to the first vector. At the same time, it should be perpendicular to the second vector. So C is perpendicular to both A and B at the same time. This will give you the direction of the vector product. For example, say you have vector A, 5 meters, 30 degrees below negative x, and then you have vector B, 3 meters per second squared, 10 degrees to the right of positive y. And then we get the vector product, A cross B. So C is a vector quantity. We need to get two things, the magnitude and the direction. Draw the two vectors. Vector A, 5 meters, 30 degrees below negative x. Vector B, 3 meters per second squared, 10 degrees to the right of positive y. Draw the two vectors, connected tail to tail. You'll be able to get the angle between A and B. So 30 degrees plus 90 plus 10, theta will be equal to 130 degrees. To get the magnitude of vector C, so magnitude C is just equal to magnitude of the first vector A times magnitude of the second vector B times sine of the angle between A and B, 130 degrees. And that will give you the magnitude of C. Magnitude C is 11.49066665 meters squared per second squared. Again, the units will multiply. Meters times meters per second will give you meters squared per second squared. So that's for the magnitude of vector C. Now for the direction of vector C. Again, for the direction of the vector product, use the right hand rule. So, place your right hand on the drawing, orienting your thumb with the first vector. First vector is A. So your thumb must be pointing in this direction, and the rest of your fingers will point in the general direction of the second vector B. And if you do it properly, your palm will face in the direction of the vector product C. If you do it properly, vector A, your thumb, vector B, second vector, your fingers, your palm. If you do it properly, your palm, the direction of vector C, your palm will be heading towards the paper or board or screen. If you do it on the screen of your computer, the vector product will be heading towards negative Z direction, into the board, into the paper, or into the computer screen. So the final answer is vector C is magnitude that you calculated and the direction that you determined using the right-hand rule. Vector C is equal to 11.491 meters squared per second squared towards negative Z. Unlike scalar product, if you reverse the direction of the reverse the order of the multiplication, it will result in a vector product that has the same direction but heading in the opposite direction. So, if vector D is B cross A and vector C is A cross B, B cross A is reverse order as A cross B. So, B cross A is equal to negative of A cross B. Negative of a vector, the magnitude will be the same, but the direction will be reversed, will be in the opposite direction. So that means, if D is equal to B cross A, C is equal to A cross B, D is equal to negative C. As with the scalar product, we can also use vector product with vectors that are in unit vector notation. So again, we have A is equal to AX I hat plus AY j hat plus AZ k hat. Vector B is equal to BX I hat plus BY j hat plus BZ k hat. If you now get A cross B, you get vector C, vector product C. Vector product C is just equal to AY plus BZ minus AZ BY quantity times I hat plus AZ plus BX minus AX BZ times J hat plus AX BY minus AY BX times K hat. You can memorize this equation for the vector product with unit vector notation. You can memorize this equation, or you can use the following matrix method to help you remember or to help you derive the equation. Write down the components AX, AY, AZ, first vector, and then components of the second vector, BX, BY, BZ. Write them down in matrix form. So AX, BX, I hat column, J hat column, you have AY, BY, K hat column, AZ, BZ, and then extend the matrix. Extend the column I hat, and then J hat. For I hat, cover up the first column of I hat and then cross multiply the J hat and K hat column. So AY times BZ minus AZ BY, that will give you the I hat. So again, AY BZ minus AZ BY. If we go to the previous slide, you got AYBZ minus AZBY times I hat. Then for the J hat, for the Y component of the vector product, cover up J hat, and then cross multiply K hat and I hat columns. So, AZ BX minus AX BZ. Again, AZ BX minus AX BZ times J hat. AZBX minus AXBZ times J hat. And then, move on to the next column, K hat, cover K hat, and then cross multiply I hat and J hat columns. So, AXBY minus AYBX times K hat. So again, that's AXBY minus AYBX multiplied by K hat. AXBY minus AYBX multiplied by K hat. So you can either memorize this equation or remember this method of determining the equation. And that's it for our discussion on vector product. That's it for our discussion on the topic of vector algebra. So thank you for watching.